In this video, we are going to talk about solving inequalities, specifically linear inequalities, and graphing the solution. Remember, with an inequality, we get more than one solution. We typically get a less than or greater than, and so half of our number line ends up being values that would make the inequality a true statement. Remember, you are watching, you are listening, and you are taking notes on your guided notes half sheet. Okay, so first of all, we have our golden rule of inequalities. I want you to write this down and I want you to really think about and remember it. Whenever you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. Now, other than that, solving an inequality is exactly the same as solving an equation, linear equation. So you're still using your properties of equality, your addition properties, subtraction properties, multiplication, and division properties of equality to isolate your variable. We just have to remember, anytime you multiply or divide both sides of an inequality by a negative number, you need to flip the inequality sign. Okay, so let's take a look at writing down our steps for solving an inequality. The first couple of steps are actually just the solving. So we're going to simplify both sides, which means eliminate grouping symbols, combine your like terms, and then we're going to get the variable on one side. We're going to isolate the variable. I'm sorry, we're going to make sure that the variable is just on the left or just on the right, not in both places. Then we're going to isolate the variable. So these two steps are just the solving. Now make sure to use the golden rule. Anytime you multiply or divide by a negative number, you need to flip the inequality sign. So a less than will become a greater than will become a less than. Okay, the next step, you're just going to quickly check your order. You want it to be variable, then your symbol, then your constant. So in other words, you want your answer to look something like x is less than 3. Okay? If it says 3 is greater than x, you're going to want to flip it around. So 3 is greater than x is the same as x is less than 3. That'll help us to make sure that we graph the solution properly. So this one's just a little quick check before we move forward. Step 4 and 5. First, you're going to, on your number line, circle your number. So for this example here, I would circle a 3, and then I'm either going to shade to the left or to the right. So this is our graphing the solution on a number line. Okay, so we have 3 basic things we're doing. First, we're solving, then we're doing a quick check, and then we are graphing our solution on a number line. If you need to pause here to get these written down, go ahead and do so. And then we're going to move on to the next thing. Okay, before we look at our example here, I just want to remind us an open circle is when we have a greater than, or sorry, that's a less than, or a greater than. A closed circle, less than or equal to, greater than or equal to. So remember, if it has the or equal to, we want to include the number. If it doesn't have the or equal to, we need to use it as a border. So we have to do an open circle. Okay, we have an equation that we're going to solve here. And I'm actually going to solve it in such a way that we have to divide by a negative. So I want to make sure we all understand what I mean by flip the inequality. There are multiple first steps that you could do. I'm going to have us do getting our x's together. Notice, by the way, I don't need to simplify. There's no grouping symbols. There's no like terms on the same side. So I'm going to get my x's together. I'm going to do that by subtracting x from both sides, lining it up with its like term. So I get on this side 13, and then here signs are the same, so I add and keep the sign. Is less than or equal to 13. So 5 minus 4x is less than or equal to 13. And then now I want to isolate the x. So I'm going to start on the same side but furthest away. Remember, this is a positive 5, so I'm going to subtract 5 from both sides. The minus is going with the 4x, not with the 5. So I have negative 4x is less than or equal to 13 minus 5, which is 8. My last step here, negative 4 times x is less than or equal to 8. The opposite of multiplication is division. So I'm going to divide both sides by negative 4. Now right there you should have bells and whistles going off in your head. I divided by a negative, so I need to change my inequality signs. I divided by a negative, so I need to change from less than or equal to greater than or equal to. So that's what I mean when I say flip the signs. Okay, now we need to graph. I am going to do my quick check. I've got variable, then inequality, then my constant. Next I need to graph. Pause here if you need to. All right, so I've already drawn our number line here. I need negative 2. So I'm going to go actually just a little bit further down. I'm going to go to negative 3, negative 2, negative 1, 0, 1, 2, 3. So each little hash mark is one of my integers. Now, because I have the or equal to, this is going to be a closed circle on negative 2. And then it's greater than, so all the numbers bigger than negative 2 will make this statement true. So bigger than is going to the right. All those numbers are bigger. So if I plug in 2, 2 is greater than or equal to negative 2. That is true. If I plug in negative 1, negative 1 is greater than or equal to negative 2. That is true. If I come back to my original and plug in 0, 0 is easy to check because it gives you 0. Right? So here I have 5 minus 0 and 13 plus 0. 5 is less than or equal to 13. It's true. So all my ones that are shaded on my number line here make the inequality true. By the way, that includes my fractions and my decimals. So 2.25 makes it a true statement. That's why we're shading all of those values. So again, solving an inequality is basically the same as solving an equation, except when you multiply and divide by a negative number on both sides, you need to flip your inequality sign. And then when you are done, you can graph your solutions, because you've got more than one there. You've got actually infinite. You can graph your solutions on the number line.